Welcome back to my channel. In this video, we will learn the topic classification of signal in digital signal processing. The major classification of signals are energy and power signal, odd and even signal, periodic and aperiodic signal, causal and non-causal signal. First, we will see what is energy and power signal. For any discrete time signal x of n, the energy of the signal, that is total energy of the signal, is given by the formula E is equal to summation n equal to minus infinity to infinity modulus of x of n the whole square. For this is for discrete time signal. The same formula for continuous time signal is E equal to integration of minus infinity to infinity x of t the whole square, modulus of x of t the whole square. So for continuous time signal, you have to use an integration formula, and for discrete time signal, you have to use summation. And the average power of the discrete time signal is P equal to limit n tends to infinity 1 by 2n plus 1 summation n is equal to minus n to capital N modulus of x of n the whole square. And this is for discrete time signal. And for continuous time signal, P equal to 1 by 2t, that is total period, integration of minus t2 plus t modulus of x of t the whole square, where limit t turns to infinity. Okay, so P is equal to limit t turns to infinity 1 by 2t integration minus t2 capital T modulus of x of t the whole square. And this is the formula to calculate energy and power of any discrete time signal and continuous time signal. And next, we will see what is energy signal and power signal. So for energy signal, the total energy which is calculated by this formula should be an finite value, and the average power should be 0. If energy is finite and power value is 0, then that signal is said to be energy signal. If total energy is infinity and average power is finite, then the signal is power signal. This is the condition for energy signal and power signal. So before getting into this problem, let us see some finite summation formula and infinite summation formula, which is useful to solve the problems. So first, infinite summation formula, which is used in this problems, that is energy and power calculation problem. Summation n is equal to 0 to infinity a power n, that value is equal to 1 by 1 minus a, if modulus of a value is less than 1. Example, if your a value is 1 by 3, which is less than 1, so in this case 1 by 3 power n equal to 0 to infinity, then the solution is 1 by 1 minus 1 by 3, right? But if the modulus a value is greater than 1, the magnitude of this a is greater than 1, definitely the summation becomes infinity, because we are going to add that value until infinity, and that value will keep on increasing, because if you put a is equal to 2, which is greater than 1, then what will happen? Summation n equal to 0 to infinity 2 power n. So for n is 0, you get 2 power 0, 1. And for n is 1, you get 2. Then n is 2, you get 2 power 2, 4. Then n is 3, 2 power 3, 8. It will goes on. So 2 power, last value is 2 power infinity, which is almost infinity. If you are adding all these values, you get definitely infinity. Okay, so if the magnitude value is greater than 1 for this a, then definitely the summation value becomes infinity. Similarly, if you put that magnitude which is less than 1, n equal to 0 to infinity 1 by 3 power n, or 1 by 2 power n, which is less than 1. In this case, when n is equal to 0, 1 by 2 power 0 is 1 plus. When n is equal to 1, 1 by 2 power 1 is 1 by 2. Then n is equal to 2, we get 1 by 2 power 2, that is 1 by 4. The next one is 1 by 8. So the value is decreasing. 1 by 2, that is 0.5, this is 0.25, this is 0.125. So this value is this value is decreasing by increasing n value. So at n is equal to infinity, 1 by 2 power infinity, that is almost equal to 0, right? So definitely you get a finite value for this summation, that is equal to 1 by 1 minus a. Right. Next one is finite summation formula. Summation n equal to 0 to n minus 1 1, that is equal to n. That means you are going to add 1 from 0 to n minus 1. Otherwise, you are going to add 1 by n times, right? 0 to n minus 1. So 0 to n minus 1. So from 1 to n minus 1, you have a n minus 1 values, and at 0, you have one more value. So n minus 1 plus 1, you get n. So totally 0 to n minus 1, that is equal to n times. So we are going to add n times 1. So n into 1 is equal to n, right? The next one, summation n equal to 0 to n a power n. Solution is 1 minus a power n plus 1 divided by 1 minus a. So sometimes you may have summation n is equal to 0 to n minus 1 a power n. So there is slight changes in this solution. Here n, you get n plus 1. If you have n minus 1, then you get a power n. Just what is the value? You have to add 1 with that value and you will get here. Okay. So, and this is for a is not equal to 1, right? If a equal to 1, what will happen? If a equal to 1, 1 power anything is equal to 1, right? Here you get 1. Summation n is equal to 0 to n. 0 to n means total value 0 to n, then the total value is n plus 1, right? So 0 to n times you are going to add 1, that is n plus 1 times you are going to add 1, right? So 1 into n plus 1. Okay, n plus 1 times you are going to add 1. So the answer is 1 into n plus 1. So that is here n plus 1 if a value is 1. So next one, summation n is equal to minus n to n 1. So you are going to add 1 from minus n to plus n. So for example, if we are taking x-axis here minus n and this is 0 and n. From 1 to minus n we have n values, and from here positive side 1 to n you have n values. Here n times, here n times, at 0 there is 1 value. So totally here n times plus at 0 1 time plus here in positive side n times. So n plus 1, that is 2n plus 1 times you are going to add 1, right? So minus n to n, here n times, at 0 1 time, and here n times. So totally 2n plus 1 times you are going to add 1. So the answer is 2n plus 1 into 1, that is 2n plus 1. Let us see one problem in energy and power signal. Here determine the energy and power of the following signal. Find whether the signal is energy or power signal. And the signal is x of n is equal to 1 by 3 power n u of n. First, write the formulas. Energy, summation n equal to minus infinity to plus infinity modulus of x of n the whole square. And for power, limit n tends to infinity 1 by 2n plus 1 summation n equal to minus n to plus n modulus of x of n the whole square. So first we will calculate energy, right? So energy E equal to summation. Before that, let us find the value of x of n. Here x of n is equal to 1 by 3 power n. Directly we can substitute, or for beginners I will explain how to find x of n. Here x of n is equal to 1 by 3 power n u of n. We all know what is u of n. U of n is a unit step signal, and u of n is equal to 1 for n is greater and equal to 0 and 0 for n is less than 0. It is multiplied with 1 by 3 power n to get x of n. So x of n becomes, when n is greater and equal to 0, u of n value is 1. So 1 multiplied with 1 by 3 power n, you get the same value 1 by 3 power n, right? So this is for n is greater and equal to 0. And for n is less than 0, u of n value becomes 0. 0 multiplied with anything is equal to 0. So x of n is also 0 for n is less than 0. So for beginners, first find what is the value of x of n, then substitute that value in this formula. Right? So you get energy is equal to, here actually in this limit you have n is equal to minus infinity to plus infinity, but your x of n value is from n is 0, right? So for negative values of n, the value is 0, so no need to write the negative values of n in this summation. So you can change the summation as n is equal to 0 to infinity, because for negative values of n, x of n becomes 0. Okay, and x of n, what is the value of x of n? That is 1 by 3 power n. So put it here, 1 by 3 power n whole square. Modulus of 1 by 3 power n is also 1 by 3 power n because it is a real number. So you get E equal to summation n equal to 0 to infinity 1 by 3 power 2n. Okay, that is summation n equal to 0 to infinity 1 by 3 power 2, that is 1 by 9 the whole power n. This summation is similar to summation n equal to 0 to infinity a power n. We know the solution for this summation, 1 by 9 which is less than 1, the value is 1 by 1 minus a. Already we have seen this. So energy is equal to 1 by 1 minus 1 by 9. A value is 1 by 9. So the answer 9 minus 1, that is 9 by 8. If you solve this, you get 9 by 8. This is energy. Then next we will calculate power. Power P is equal to limit n turns to infinity 1 by 2n plus 1 summation. Here also in this summation have minus n to plus n. We can avoid negative values of n. So n is equal to 0 to n and x of n value is 1 by 3 power n. That is whole square. Right? So limit n turns to infinity 1 by 2n plus 1. This becomes n is equal to 0 to n 1 by 3 square, that is 1 by 9 whole power n. It is similar to summation n equal to 0 to n a power n. Right? Answer is 1 minus a power n plus 1 divided by 1 minus a. So we get limit n tends to 0 1 by 2n plus 1. Here the answer for the summation is 1 minus a value is 1 by 9. 1 by 9 power n plus 1 divided by 1 minus 1 by 9. Okay. Next, substitute the limits. N is infinity. So n infinity 1 by 2n. If you put infinity here, you get 1 by infinity, right? And here 1 minus 1 by 9 which is less than 1, right? 1 by 9 power infinity 1 by 9 which is less than 1. If the value is less than 1, then if power increases, then the value becomes, so 1 by 9 power infinity. Here this value is less than 1, right? If the value is less than 1, we all know value less than 1 means if you are increasing the power, then the value will reduces. For example, 1 by 2 power 1 means 1 by 2, 2 means 1 by 4, 3 means 1 by 8. So it is decreasing. So 1 by 9 power infinity definitely equal to 0, approximately equal to 0. So you can put this value equal to 0, then you get 1 minus 0 divided by 1 minus 1 by 9, and 1 by infinity you get 0. Power value is 0. Energy value is 9 by 8 which is finite, and power value is 0. So the signal is energy signal. Energy value is finite, that is 9 by 8, and power value is 0. So the signal is energy signal.